Hello, electrical enthusiasts. Welcome back to the channel. Today, we're taking you inside a 132 kV substation to demystify one of its most critical components, the isolator. We'll explore its purpose, look at its intricate connections, and even witness its operation up close. Get ready for a high-voltage learning experience. First, let's understand, what exactly is an isolator? In simple terms, an isolator, also known as a disconnect switch or disconnector, is a mechanical switching device used to isolate a section of an electrical circuit. Crucially, unlike a circuit breaker, an isolator is not designed to interrupt fault currents or even normal load currents. It's operated only when the circuit is already de-energized by a circuit breaker. Think of it as a visible break in the circuit, providing a safe working clearance for maintenance personnel. A typical 132 kV isolator consists of several key parts. Live blades or contacts. These are the moving parts that physically connect or disconnect the circuit. Insulators. The tall ceramic or composite insulators provide electrical isolation from ground and support the live parts. These are vital at high voltage operating mechanism. This is the mechanical linkage that moves the blades. It can be manual, lever operated, or motorized, support structure or frame, the robust frame that holds everything together. Now let's dive into the control box, the brain behind the isolator's operation. This box typically houses the motor. For motorized isolators, this motor drives the operating mechanism. Control circuitry, relays, contactors, and terminal blocks for remote operation and interlocking. You'll see connections for the DC supply, usually 110 volt or 220 volt DC, that powers the motor and control circuits. The jumper connections. Here allow for flexible wiring and configuration, often for interlocking or status signaling, ensuring sequential operation with other equipment. Let's witness the operation. Here we see the isolator being operated. Notice how the blades slowly move to create a visible air gap. This clear, physical separation confirms that the downstream equipment is truly isolated and safe for work. Once the blades are fully open, the circuit is considered de-energized. When closing the isolator, the reverse sequence is followed. Ensure the circuit breaker is open, then close the isolator blades, and finally, close the circuit breaker to restore power. And there you have it, an in-depth look at the high-voltage isolator, its components, control, and vital role in our electrical substations. We hope this video gave you a clearer understanding of this silent workhorse of the power grid. If you found this video informative, please hit the like button, share it with your fellow engineers, and don't forget to subscribe my channel, Power Pulse, for more insights into the world of electrical engineering.